What I want to look at now are what are called piecewise-defined functions. Piecewise-defined functions give people trouble because we expect functions to behave a certain way, and we expect them to behave actually rather simply. And piecewise-defined functions do behave simply, it's just they look complex, and so that can maybe scare us a little bit. Here's an example of a piecewise-defined function. It has multiple ways to calculate its output. Here's one way maybe. These are just, I'm making these up. F of x equals x if x is less than -2. F of x equals 3 if x is between -2. Let me make some more room there, sorry. If x is bigger than or equal to -2 and also less than 4. And finally, f of x equals x squared minus 7 if x is bigger than or equal to 4. Okay, so this function can equal x if this is true, if the input is less than -2. It could equal this output if the input x is between -2 and 4. And finally, it can equal this output if x is bigger than or equal to 4. Okay? So, the way to look at this is, these guys here are the outputs of the function, and it depends on the type of input. Okay? So that's the idea. So let's say I ask you the question, determine, let's say, number 1, f of 0. So this means that my input, or x, is 0. So I come up to my definition of my function here, and I locate which of the three criteria here fits the input that I have down here. Well, the input is 0. 0 is not less than -2, so I'm not going to use that. 0 is between -2 and 4. So my output is going to be this. So f of 0 equals output of 3. Number 2, let's look at f of 4. F of 4 equals, well, my input is 4. So my input is not less than -2. It's not bigger than -2 and less than 4. It's not less than 4, so that's out. It's actually equal to 4, so this is the definition that I'm going to use. So my output is going to be this output, x squared minus 7. Now sometimes people make this mistake and write x squared minus 7. Well, that's wrong. Because remember, this is x, so I actually have to plug that in for my x value. So f of 4 equals 4 squared minus 7, which is 16 minus 7, or 9. Okay? And then my last one, let's look at f of -3. Well, my x value is -3, which is less than -2. So this is what I'm going to use, and my output is x. That tricks people up too. Well, x is -3, so the output is -3. So anytime your output is x, your output is the same thing as your input. Okay? Don't let that confuse you. So there's a simple example of evaluating a piecewise defined function. You just have to determine where your input lives and then choose the appropriate output from that. Okay, good.